Hi everyone, we are from Group 6 and today we are going to show you our project that we work for LifeStory Health Inc. Before we talk about what we did, let's get to know about the company. LifeStory Health Inc. is a company that leading a pioneering journey into the previously undiscovered territory of female biology, early predetermination and detection of disease, and potential disease management through effective diagnosis and subsequent therapy target. In this project, we create an interactive dashboard in RShining for displaying the data. We also analyze the unlabeled data and define the category of the data. In the classification part, we use machine learning and linear regression. We use RShining to display and analyze data. In the dashboard, user can choose the variable and the size of bin to get a histogram of the data. For example, they can choose X matches in the variable part and 10 for the bin size. We can tell that the sample distribute in the interval from 0 to 2000. In order to know more about the data, we can also use the box plot for more detail. On the left side, we can see the top size of peptide is between 500 to 4000. And on the right side, we can see the peptide identification, the amino acids that from different kind of peptide. Here we can give you another example. If the user want to know more about the retention time, they can choose the variable of observe RT minute columns. And we can see most of the sample concentrate in the interval from 20 to 40 minutes, and the sample size between 15 to 60 minutes is very small.
In this part, we can see that the patients we are analyzing are born from 1970 to 2000. Among them, the largest three groups are born in 1981, 1985, and 1983. In this slide, we are trying to figure out the correlation between patients and the zip code, periods and the flow and the cramping. We can see that there is a strong positive correlation between patients and the zip code, which is 0.8. There is a moderate positive correlation between the flow and the cramping, which is 0.3. And there is a negative correlation between periods and the cramping, which is negative 0.5. In this slide, based on three different period situations, which are irregular, regular, and regular when on pill and irregular when not, the most counts of periods are regular, while the least counts are regular when on pill and irregular when not. In this slide, the flow of periods is divided into 6 parts, including light, light or heavy, moderate, light to moderate, light and moderate, and severe. We can see that the most counts of patients' flow are light and moderate. In this slide, the cramping is divided into 5 different levels, including mild, mild or severe, moderate, no, and severe. The most counts of patients cramping are no cramping, and the least part of patients cramping are mild or severe. In this slide, we can see that among 8 different tampon brands, the most popular brand is Tampax.
Okay, next we're gonna discuss the peptide classification. Let's take a quick look at the data because we need to classify the unlabeled data according to the details data. Peptide of the mass is contributed by the amino acids inside the peptide. For example, peptide CCDK observed mass equals to the sum of CCDK mass, and observed mass equals to observed mg times charge. We will classify the unlabeled data based on the following variables: the mass and RT, intensity, mg, and charge. We'll attempt to use the machine learning to solve the problem. In this case, we use PCA dimensionality reduction to find the main components contribute to the peptide categories. In other words, we use this method to know the main variables influence peptide classification. This bar chart shows the 5 variables ratios of contribution to the peptide classification. In supervised machine learning process, we use details data as training and testing dataset. We drop the last component because the last component just have a little barely non ratio. So we drop the last component to improve the accuracy. And we can see from the decision tree and the random forest, we have the two highest accuracies. However, you can find that the accuracies are very low. One is 75, and one is 45, and one is 44. The reason why we cause this such a low accuracy. Classify the peptide is a process of calculate microunit, and distinguish the category required a great deal of precise calculation. And another reason is that maybe using non-linear model is not the best way to classify this kind of data. So we try to find if the data has a linear relationship, so we can classify the unlabeled data in the higher accuracy. We can see from the correlations matrix and the heat map, observed mass and charge have super high correlation coefficient with peptide categories, almost near 1. And we just use observed mass and charge for the variables to build a linear regression model. And after we build this model, we can calculate the accuracy is almost 90%. It's very high. So on the right hand side, this is our final classification of the unlabeled data. Also, if we want the higher accuracy, we may need more data in different peptides so that machine can process a lot of calculation to improve the accuracy. We believe machine learning in medical industry will perform well, but you still need a large amount of data to train the machine. In order to create a dashboard for researchers to see the difference among several mass chromatogram, we might need to stack the picture together, and these pictures must be transparent so that we can compare the fluctuation between each other. Unfortunately, we are still working on it. It is actually a complicated process to accomplish. The package and the reference website may provide some useful information for you guys to figure it out.